Hello, today I would like to show you how often I connect the wires to the tracks. Because very often I would be asked, hey, how many connections do you have? And it's equal if it is on Facebook or if it is on the in Bremen when I do the exhibition. They ask, hey, how many cables you have connected to the trains or to the tracks. And very often I can just say, hey, it depends on your layout. If you have just a little layout with a little circuit, you don't have to do it very often. If you have a layout like mine, I have 100 meters of tracks for one circuit. Then you have to do a little bit more connections from the power supply to the tracks. But this I will show you today. I will do a few examples on the paper, and then I will show you on the layout behind how many connections I have. If you have questions, send me a comment or send me an email. I will try to answer it for you. Now we do start with the theory on the paper. So the first example is it's very easy. It's just the circle, the normal Märklin standard circle. It's the 6 curve each and one straight track. For this case, I have just one connection from the transformator to the tracks. Let me do it in 2 colors. Yeah. I have a test circuit with the curves and 10 straight tracks on each side, and I use just one connection to the tracks. It's enough. You do not need so much. So I put it a little bit more to the camera. That's very easy. If you have more straight tracks, or if you have it here and it becomes a little bigger, it's not bad if you do the connection also here and here and here. Yeah. Here there's the transformer. Then you have the a good connection. So it would be working probably good. A different thing is, for example, if you have the circuit and then you have a extra track and you have a disconnect, powerless connect to stop trains. Not powerless connect. If you have a track without power, you put the power by a switch or a relay or a signal. The old Märklin signals, they have the contacts to put the power or to supply the power to the tracks. For this case, I would do there's the transformer. I have the normal connection to the tracks. But in this case, you don't have the connection around because it's interrupted here. And in this case, it depends what side do you take. In this case, I put the connection also there and there to the track. This I will do by a switch, so you can switch it on, switch it off. And then I will do the connection here and here, because then you have the same power here, 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 and in the 2 interrupted tracks. This is something what I did because my experience. Before I did it the TED scale, I was in the HO. I used Märklin HO, and when I was young, I had this. The train was going to the stop track, and in this case it was running very fast because I had the connection from here directly to the transformer. And after this I decided I do the connection before and after the stop track, so I have the same power here and here. So that's very easy. If you have it a bigger layout, you do a little bit more connection to the tracks, and that's it. I don't say do it every meter or every 2 meters. It's the feeling. You can test it. Use a locomotive and let it run, and if you see after the stop track it becomes a little bit slower or it becomes faster, then you can do the connection. Another example is you have a straight track, you have here and here an interrupt to stop trains. So you have connected to the transformer. So you have to do this also, because otherwise you don't have the power there. This you put it on the switch, and this directly to the transformer. Yeah. So it's not that bad. If you have more connections to the tracks, it's better than have less, because when you fix it and you have the basalting and everything, it's done. It's more difficult to put another connection to the tracks, because you have to redo everything what you have done before. So put a little bit cable more on the tracks and everything will be good. Now I will show you on my layout just a few examples, and then you can decide how you want to do it. So now I will use the same example like in the German video before. Here there's my main station, and for each track, on this track, for example, I have 4 connections to the wires. But in this case, it's the reason because I use the power sensors. If there's a lock inside, the sensor will say to the computer, hey, the engine is here. That's the reason why I have a little bit more connections to the tracks than it must be. For example, the train comes from here, and in this case, on this track, it knows, hey, I have to brake, and here I have to stop. Also for the other direction, because this is why I have 4 connections. I can run the trains in both directions in the station. I can use every track in both directions. So in this case, here it runs normal in this way, and in the middle of the track it knows I have to stop. So it starts to brake slowly until it arrives at the signal tower, and in front of the signal tower there's another sensor, and it says, hey, you have to stop, and the engine will stop. If you don't drive digital, you have not to do this, because the sensor you don't use. Then you need the power connections just to put the power on the tracks, not for the sensors. So let's go to the next. So these tracks are right behind my main station, and also here I have the sensors and so I have to do the connection from the sensor to the track. But I will show you on the paper why and how. That's yeah. So on the layout I have a lot of connections. 2 years ago I was asking my community, hey, how many sensors I have, and yeah, I have more than 30 sensors with 8 track connections. So there are a lot of connections to the tracks on my layout. So now this is what I was telling you before. This is my sensor kit with 8 connectors. It's like this. So you have the track interrupted every few meters, and then you have to connect the sensor kit to the track, and this goes to the power supply. So for example, the train is coming from here and arrive here, so the computer software will know, oh, the train is here. In the next area it knows, yeah, now I'm here and I have to brake because here I should stop. That's why you use the sensors. And this kind of sensor knows there is a consumption of power. So the train is arriving here, the engine needs power and is going through the sensor kit to the track, and then it says, yes, on connector 1, 2, 3 there is a consumption, the train must be here. And it works even with the locomotive or with wagons with light. So of these kits I have 30, and then with 8 connectors. So now you know how many connections to the tracks I have. So I hope my description of the connections to the tracks from the wires was clear, and you got it. I know my English is not so good like yours, but I hope you could understand me. Yeah. You see, you have difference between digital and analog. In digital, normally you don't have the powerless track sections, because if you want to stop a train, you say to the train, hey, you have to stop. And in analog, you have to switch off the power. And so there's another way for the power supply. With the analog, it's I wouldn't say it's more difficult or it's easier. It's just another way. You put the power to the powerless track by a switch, so you can switch it on, switch it off. And in digital, you can say stop here, and everything is good. Also at my layout, I have powerless tracks because I have 103 addresses for locomotives, and I have a little bit more than 103 locomotives, so I have to think about the way how I can manage this. And I decided locomotives what I don't use, what are not running at the moment, I put on a track, put the power off or switch the power off, and I can use the same address for another locomotive. Yeah, that's the reason why I have powerless tracks on my layout. And analog, if you want to stop a train, you have to switch the power off, or you have to use another circuit, a power circuit, and that's what you have to manage. That's everything what you have to do. The connection of from the wire to the, or from the transformer by wire to the track, it's always the same. I'm not a friend of saying, hey, you have to do it every 50 centimeters or every 100 centimeters, or every 3 meters or 5 meters or whatever. A good way for me was if you have a interruption track or powerless track, you put this over a switch, and before and after this you have to connect to the transformer. That's a good way to have everywhere the same power. Good example was in my childhood. I had the Macklin HO, and on the wall there was 2 tracks, a main line in Germany we say, and it was in a curve. Then there was a signal tower, and the train was stopping by the signal. I switched the signal on, and the train was going fast, starting very fast, and the last wagons was falling down. Because if you have different powers, the train is going slower, get fresh power and runs away. And that's something what we don't want. So if you have the power connectors that by the wire, every few meters or whatever, or after a few power interruption tracks, it would work very well. And I guess you would get problems with powerless sections. A good way is try put a train on the layout, let it run before you do anything on the landscape. So you can see the train is running good. You see it becomes slower. Then you put another connection to this part, and if you see there's a speed difference, it becomes faster. Yeah, then you see there is something with the power strange, put their connection, and everything is good. But this is something you should do before you do something on the layout, because if you have started to do the landscaping, you have to remove it and have to connect the cable to the track, and everything you have to do again. So that's the reason why you should test before the landscaping. Yeah, I hope now it's clear. If not, send me a comment or send me a comment. Send me an email. I try to explain a little bit more, a little bit different. If you have questions to specify topics, I will try to find the answer. So have a good week, stay safe, see you next time.